The U.S. Air Force is facing a nightmare scenario, a massive capability gap as sixth-gen fighter costs spiral out of control. While heavy platforms struggle to stay on budget, a lethal solution is emerging from the Arctic. Is the Swedish Gripen E the affordable, software-defined bridge needed to maintain air superiority? Future wars won't be won by airframes alone, but by the code running inside them. The Gripen E's modular architecture and advanced electronic warfare suites are rewriting the rules of engagement in NATO theaters. Discover how this agile fighter uses autonomous networking to outsmart threats that even the most expensive jets can't touch. What if the secret to American air dominance isn't a trillion-dollar American jet, but a Swedish masterpiece? As high-end threats escalate, the Gripen E offers a lethal, cost-effective alternative to fill the looming sixth-generation void. It's time to look at how modularity and Swedish engineering are securing the contested skies of tomorrow.
The United States Air Force is entering a dangerous transition window, not because it has lost air superiority today, but because the aircraft meant to guarantee that superiority tomorrow are arriving too slowly, costing too much, and facing pressure from every direction. The next-generation air dominance program, now centered on Boeing's F-47, was officially pushed forward in March 2025 when the Air Force awarded the engineering and manufacturing development contract. But this was not a normal fighter program. Before that decision, NG8 had already gone through a strategic pause, budget pressure, and design reassessment, because the original vision of a revolutionary sixth-generation fighter was becoming extremely expensive. Reuters reported that NG8's development budget was about $28.5 billion over 5 years, with the total program potentially rising well beyond $100 billion if around 200 aircraft are produced. And that is where the real problem begins. The F-47 may become the most advanced fighter ever built, but it is not available in numbers today. In March 2026, a leading U.S. lawmaker warned that the F-47 may not be truly available until the mid-2030s, meaning the Air Force must keep older fighters alive much longer than planned. The F-15CD fleet is already being stretched into 2030 for homeland defense, even though more than 75% of those aircraft are performance-limited because of structural fatigue. The F-22, America's elite air superiority fighter, remains powerful, but it is a small, aging fleet that was never bought in the numbers originally planned. So this is not just a budget story, this is a timing crisis. The United States is trying to cross a bridge from fifth-generation dominance to sixth-generation warfare, but the bridge is longer than expected, and the aircraft holding it together are aging under pressure. Every year the F-47 remains in development, the burden falls harder on F-22s, F-35s, F-15EXs, and legacy airframes that were never designed to carry this strategic weight forever. Nowhere is this gap more dangerous than in the Arctic and Northern Europe. This theater is not like the Middle East, where large bases, tankers, and predictable routes can support air operations. The High North is cold, vast, remote, and brutally unforgiving. In March 2026, Exercise Cold Response 26 brought more than 25,000 personnel from over a dozen NATO nations across Norway, Sweden, and Finland, specifically testing operations in harsh Arctic conditions. U.S. F-35s flew alongside Norwegian F-35s, Finnish FA-18s, and Swedish Gripens, proving that future air superiority in this region will depend not only on stealth, but on speed, endurance, interoperability, survivability, and the ability to operate under extreme conditions. And this is where the story shifts. The question is no longer whether the F-47 will be powerful. It probably will be. The real question is, what protects NATO's northern flank before sixth-generation air power arrives in meaningful numbers? Because in the Arctic, a capability gap is not just a technical delay, it is an open window. And that window is exactly where Sweden's Gripen E begins to matter.
The real revolution behind the Gripen E is not just its engine, radar, or weapons load. It is the way the aircraft thinks. Saab designed the Gripen E with a split avionics architecture, separating flight-critical software from mission system software. In simple words, the code that keeps the jet safely flying is protected from the code that controls sensors, weapons, electronic warfare, cockpit displays, and tactical upgrades. That matters because a new threat does not always require a new aircraft. Sometimes it requires a new line of software, and Gripen E was built to absorb that change fast. Saab says this architecture allows mission systems to be updated without forcing the entire flight control system through costly recertification every time a new capability is added. This is why analysts often compare Gripen E to a smartphone-style combat platform. You do not rebuild the phone every time an app changes, you update the app. In Gripen's case, the apps are not entertainment. They are radar modes, threat libraries, electronic warfare responses, cockpit logic, sensor behavior, and weapons integration. Saab has said Gripen E software updates can be made within hours, and Flight Global reported that Saab sends up to 10 configuration updates per week into flight test work. That does not mean every battlefield update is instantly pushed into combat without testing, but it does show the tempo. Gripen E is designed for continuous adaptation, not decade-long modernization shock. Now compare that to the American heavy platform model. The F-35 is a far more stealthy and powerful ecosystem, but its modernization cycle shows the weakness of complexity.
The Government Accountability Office reported that the F-35 Block 4 modernization effort is more than $6 billion over earlier cost estimates and at least 5 years later than originally planned. That upgrade is not cosmetic. It is tied to sensors, weapons, software, and electronic warfare capability, exactly the areas that must evolve fastest when Russia and China keep changing radar signatures, jamming techniques, missile behavior, and electronic attack patterns. This is where Gripen E becomes a great equalizer. It does not try to beat America's 6th-generation future by being bigger or more expensive. It challenges the timeline itself. In modern warfare, the aircraft that wins may not be the one with the most classified hardware on day one. It may be the one that can learn faster, adapt faster, and return to the fight with new electronic behavior before the enemy understands what changed. And the AI era makes this even more serious. In 2025, Saab and Helsing completed the first test flights integrating the Centaur AI agent into a Gripen E, using it in beyond visual range air combat testing. Helsing said the milestone was achieved in less than 6 months from concept to live flights, pointing directly to Gripen E's modern software architecture as the reason such rapid integration was possible. That is the strategic point. The future battlefield will not wait 10 years for a perfect upgrade package. AI models will improve in months. Electronic threats will change in weeks. Radar libraries may need updating in days. In that environment, Gripen E is not just a fighter jet. It is a software-defined combat node. And for the U.S. Air Force, facing a vulnerable gap before 6th-generation aircraft arrive in real numbers, this kind of adaptable platform could become more than a partner aircraft. It could become a temporary bridge between today's aging fleet and tomorrow's unfinished airpower revolution. Gripen E is not a stealth fighter in the traditional American sense. It does not try to survive by disappearing from radar like the F-22 or F-35. Instead, it follows a different philosophy. Do not only hide from the enemy, confuse him, blind him, and force him to waste time chasing a false picture of the battlefield. This is the idea behind Gripen E's electronic stealth advantage. In the 2026 radar environment, physical stealth alone is no longer a complete answer. Modern air defense networks are becoming more layered, more digital, and more connected. Low-frequency sensors, passive detection systems, electronic support receivers, and multi-static radar networks are all designed to make the sky harder for any aircraft to cross silently. That is why electronic warfare is no longer a support feature. It is becoming a survival system. This is where Gripen E's internal electronic warfare architecture becomes dangerous. Saab's Arexis system is designed to give the aircraft both defensive and offensive electronic warfare capability, detecting threats, deceiving sensors, and countering hostile radar behavior in real time. Saab describes Arexis as using fully digitized receivers and gallium nitride-based ASA technology, giving it high output power, better bandwidth, and stronger jamming potential than older systems based on more traditional semiconductor materials. And this matters because Gripen E does not need to fight the enemy radar in the old way. Older jamming concepts often meant broadcasting power broadly and hoping to overwhelm the threat. But modern electronic warfare is more precise. It can listen first, classify the threat, then respond with directed electronic attack, deception, false targets, smart noise, or carefully shaped emissions. In other words, Gripen E can turn the enemy's radar screen into a question mark. The opponent may see something, but may not know what it is, where it really is, or whether it is the actual aircraft at all. Now, one point needs to be handled carefully. Gripen E's operational radar is the Leonardo Raven ES-05 ASA radar, known for its roll repositional antenna that gives the aircraft a wide field of regard, around plus or minus 100 degrees, improving situational awareness and survivability. The strongest confirmed gallium nitride advantage is most clearly tied to Saab's Arexis electronic warfare family and related ASA jamming architecture, not simply to a generic claim that Gripen E radar is GaN in every configuration. That distinction actually makes the aircraft more interesting, because Gripen E's real edge is not one sensor. It is the way radar, EW, data links, software, and pilot decision-making work together.
This is the difference between physical stealth and electronic stealth. Physical stealth reduces the chance of being seen. Electronic stealth attacks the enemy's ability to understand what he is seeing. One is about shape and materials. The other is about information warfare. And in a battlefield filled with drones, AI-assisted sensors, mobile radars, and electronic traps, the aircraft that controls the information picture may survive longer than the aircraft that simply tries to remain hidden. That is why Gripen E fits the future better than many people realize. It is not just a fighter flying alone into contested airspace. It is designed to behave like a node in a wider combat network. Saab emphasizes Gripen's secure data links and network-centric warfare capability, allowing the aircraft to share battlefield information and build situational awareness across a formation. Once that network is connected with AI, unmanned wingmen, electronic decoys, and distributed sensors, the Gripen E becomes more than a jet. It becomes a digital combat manager. And this bridge to autonomy is already visible. In 2025, Saab and Helsing flight-tested the Centaur AI agent in a Gripen E, focusing on beyond visual range air combat with a safety pilot on board. Helsing reported that the Gripen E handed control to Centaur during flights over the Baltic Sea, while Saab described the test as proof of how quickly AI capability can be integrated into the aircraft. So the electronic stealth advantage is not about pretending Gripen E is an F-35. It is about understanding a different kind of survival. In the coming air war, the decisive aircraft may not always be the one with the lowest radar cross-section. It may be the one that can detect first, jam smarter, share faster, adapt instantly, and use AI-driven networks to make the enemy's entire sensor system unreliable. And that is where Gripen E starts to look less like a lightweight fighter and more like a software-defined electronic predator built for the gap before sixth-generation dominance fully arrives.
Gripen E's biggest Arctic advantage is simple. It does not need a perfect runway to stay dangerous. In a real NATO crisis, permanent air bases would be among the first targets for missiles, drones, sabotage, and satellite-guided strikes. That is why the U.S. Air Force itself is pushing agile combat employment, a model built around dispersing aircraft across smaller, harder-to-target locations instead of relying only on large main bases. This is where Gripen becomes a battlefield problem for the enemy. Saab says Gripen can operate from ordinary roads in short strips, with takeoff possible from around 500 meters and landing from around 600 meters. The wider road base concept is often described around the 16 by 800 meter standard. That means the aircraft can move between improvised road bases, hide inside the geography of Sweden, Finland, Norway, and the Arctic edge, then rearm and return before the enemy can reliably target it. And the timing matters. In 2026, NATO is visibly hardening its northern posture. Swedish Gripens deployed to Iceland under NATO's Arctic Sentry mission, while Cold Response 26 tested Allied air operations across Norway, Sweden, and Finland. This proves the High North is no longer a secondary theater. It is becoming a frontline warning chain between Russia's Kola Peninsula, the North Atlantic, and North America. The next layer is drones. Gripen E is not yet a confirmed operational loyal wingman commander in the way a sixth-generation fighter is supposed to be, but the direction is clear. Saab and Helsing already tested the Centaur AI agent inside Gripen E in 2025, and Reuters reported that Saab and Airbus are exploring unmanned fighter technology to support crewed jets like Gripen E and Eurofighter. So the aircraft is moving toward the role that matters most, a manned command node controlling sensors, decoys, electronic attack, and autonomous wingmen around it. That is distributed lethality. One Gripen is not just one aircraft. In the future network, it becomes a mobile controller, launching from a road, sharing data with NATO assets, guiding drones, confusing enemy radar, and spreading combat power across multiple locations. For the U.S. Air Force, this matters because the sixth-generation fleet will not arrive overnight. A sustainable force posture needs aircraft that are cheaper to operate, easier to maintain, faster to disperse, and useful in harsh northern conditions. Gripen E does not replace the F-47. But in the Arctic gap before the F-47 arrives in real numbers, it could help keep NATO's air power alive, mobile, and lethal.
Gripen E is not the cheapest aircraft in the world, but compared to the coming sixth-generation heavy fighter era, it is strategically affordable. Public Gripen contracts show this clearly. Brazil's original deal was $5.4 billion for 36 Gripen jets, while Colombia's 2025 deal was about $3.6 billion for 17 aircraft, including broader support and industrial packages. These are not pure flyaway prices, but they show the basic reality. Gripen E can expand air power without the financial shock of a sixth-generation fleet. Now compare that with America's F-47 NGAD path. Reuters reported that NGAD could exceed $100 billion if around 200 aircraft are built, while the Air Force's near-term F-47 development spending is already moving into multi-billion-dollar annual budgets. That means the future fighter may be powerful, but it will be expensive, limited, and slow to field in large numbers. This is why the high-low mix matters. The U.S. Air Force cannot rely only on ultra-expensive elite fighters while older F-15s and F-22s age out. If numbers collapse during the transition to the 2030s, air superiority becomes fragile. Gripen E offers a practical bridge. Lower maintenance demands, dispersed road-base operations, fast software updates, and enough combat power to support NATO's northern flank without draining the budget. Saab also emphasizes Gripen's low maintenance needs and ability to operate from extreme climates and dispersed road bases. So Gripen E is not a replacement for sixth-generation dominance. It is the aircraft that keeps the line from breaking before sixth-gen arrives in real numbers. It gives NATO more aircraft, more flexibility, more survivability, and more operational depth at the exact moment when the air power transition is most vulnerable. The F-47 may define the future, but Gripen E could protect the gap that leads to it. And in modern warfare, the side that survives the transition is the side that controls the next era. Like and subscribe for more latest defense updates. Thanks for watching.